Hey everybody, it's Michael Antonio, and welcome to this week's video, Fixing Snapshot Tests with Transforms. Okay, and it's demo time. Okay, so if you are a longtime viewer of this series, then you know that I have two GitHub projects. One is CDK Orchestration, which is my CDK library that I am using in this series, and the other one is CDK Orchestration Examples, which has all of the sample code that I have been using to show you how I like to use the CDK. And in this project, CDK Orchestration Examples, I have a number of stacks. Each lesson usually has one or more stacks associated with it, but they're all usually created by one stack. So I have an app, and then I add a service inspector aspect, which you could find out about in previous videos. And then I have this normalize snapshot example, because normalizing snapshots is what we're going to be talking about today. Now, when I organized this project, I created a constructs directory, and these are all the constructs that I'm using. And if any of them have inline Lambda code, that goes here under lambdas. And then down here, I have private, which just has the namespace that I use for runtime type info. I already did a video on runtime type info. And then here are the stacks that I use for the lesson. So for example, for the tokens lesson, here is the stack, and it has a link to the video, and I'm starting to add those now. And then here's all of the code. Now down here, I have these snapshots. So these are basically snapshots of these stacks from my unit test. So every stack gets its own unit test. So for tokens here, this is a pretty typical one. I create an app. I create my stack tokens, which is the stack for the video tokens. And then I get the template, and I change it into JSON, and then I ask if it matches the snapshot. And matching a snapshot, that's just part of Jest. And so I'm just using Jest's built-in snapshotting capability to create these snapshot unit tests. And these are really useful because if there are any changes of the template from build to build, I would like to know about that. I would like that to be flagged for me so that when I'm checking in, I know that I've changed something. And if I've changed something, maybe that means that something broke, or maybe it means that I made a change and it's expected. But, I would like to be able to just build and have a clean build and be able to check in and not have the snapshot update and not have any errors when I build. So, I found as I went on, like this works perfectly well. This is a great test. But what I found as I went on is that I was unable to achieve this goal. And the reason why is because there are a number of things that always change when I compile. For example, when I compile a custom resource that has a salt value in it, that salt is there to make sure that something in the properties of the construct changed. And the reason that that is there is so that I am able to ensure that the custom resource runs every time I deploy the stacks. And so basically when there's a build, that build will deploy. And since this salt value changed, that means that the custom resource is going to run. But it also means that my snapshot is going to update because, of course, since this salt is a timestamp, that timestamp is always going to be different for each build. And I have a variable that I use for this. And so I'll end up using the same salt value at different places in the output because I'm always using the same salt value. And that's actually kind of useful. And so I would like to make it so that when I am compiling, that these don't show up because I don't really, the fact that the salt changed, that's an expected change. So I'd like to not see that. Another problem that I found is that when I update my library, since my library ends up getting included in some of the assets for my lambdas, the S3 key ends up getting updated as well. And I'd also like to have that not happen because updating my CDK orchestration library version, I think we're at like 28 or 29 now. But at the time that I made this change, I was upgrading from 25 to 26. That is 0.1.25 to 0.1.26. And this is also fully expected that these S3 keys are going to change, and I'd rather not see those when I'm doing a compile. So I spent some time looking at how snapshotting works, and you can actually pass a matcher to this to match snapshot and tell it like, here you might expect like any number or any string or something like that. And yeah, I could do that, but there would be a lot of them to change. And I wanted to make sure that I could do this easily. Well, I realized that I already have a way of modifying JSON, and maybe I should just use that. So what I started doing is I started adding this normalized snapshot construct to my stacks. And so you can see here's my ordered transforms lesson, which is a lesson that we did, I think it was last week. And then I add this normalized snapshot to it, and this actually makes the fixes that allow the salt and the S3 key and a few other values to change between builds, and yet they won't show up in my snapshots because it changes them to a known value. So how does that work? Let's go take a look at that. Okay, so here's my stack for today's lesson. It's normalized snapshot example. It extends stack. And what I'm going to do is I'm going to add some things that I know are going to create problems for me in the snapshot. So for example, I've got this ensure change in stack. An ensure change in stack is a construct that is a wait condition handle. And what this does is say you have some metadata only changes that you want to deploy. Well, CloudFormation won't let you do that. And so you have to have a resource change. So this creates a resource change that ensures that you will be able to create a change set and you will be able to deploy that metadata when you deploy the stack. So it won't give you an error saying, hey, there's no changes in the stack. And so what this does is it sets its own logical ID to ensure change in stack with a hash value. And that hash value is based on the time. And I'm using the build time here so that I am using something which is sort of a known value. And so every time we compile this code, we're going to get a new build time, and therefore we're going to get a new logical ID. And therefore, when this deploys, the old CF wait condition handle will be destroyed and a new one will be created. So that's awesome. Okay, and so in order to make this work, I have this normalized snapshot construct, and this construct contains 1, 2, 3 transforms. And if you're interested in transforms, I'll put a link to some of the transforms videos in the description. And so what transforms do is they edit the JSON, which is output in the template.json file. And so these three, since they are part of a construct, which is going to be added to a stack, and there are no resources, either L1 or L2 resources between it and the stack, that is between these three, and their parent construct is normalized snapshot, and normalized snapshot's parent will be the stack. And since there are no L1 or L2 resources in between these three transforms will be attached directly to the stack, and they will run as part of the stack synthesis. Okay, so let's see. So let's take a look at these. So the first one that I have here is normalize code S3 key, and you can see that normalize code S3 key is a transform. And when you apply that transform, it is taking a very specific on event. So this is basically a custom resource provider function, and this custom resource provider function's S3 key will update every time I update my library references, and I don't want it to do that, so I'm just going to go ahead and set that S3 key to a known value so that every time I run, it will have the same value when I run it as part of these tests, and therefore the snapshot won't update based on the code S3 key. Okay, so then the next one that we have is normalized salt, and normalized salt is a string replacer, and a string replacer basically does a string split followed by a string join, and so I'm splitting on the build time, and I'm joining on a known build time so that, again, that value will not change. And so I don't have to, the way that I would with Jest, I would have to know every specific string that references the salt here. I can just say, well, I know what the salt value is, so if we find that in the template, then I can just replace it with a known good value, and I know that it won't change. So that's good. And then up here, I have a normalize ensure change in stack, and that normalizes that ensure change in stack resource. So if I have a resource that starts with ensure change in stack, then it will change it to a known logical ID. You shouldn't ever have two of these in the same stack, so this would work in that case as well. But it would go from 2 down to 1. But again, you should never have multiple of these in a stack, and in fact, if you look at ensure change in stack, the constructor is protected, and there's a static for that will add this to your stack using my singleton create method that ensures that what you get here is the stack and what you get here is the ID, and it ensures that what gets returned from this factory, in fact, is a direct child of the stack and has the correct ID. So this is kind of a nice way to create singletons, and this again ensures that those changes will not come out as changes in my snapshots. And so how does this work? Let's take a look at the output here so you can see that I ran this and our normalized snapshot example. So what I did is I set the log level to debug because debug log level allows us to see what transforms framework is doing. And the first thing that I did here with transforms is I did this echo. So here is where I added my resources that I know are going to have these problems where they change every build. And here I'm doing an echo. And so this is going to show you that the ensure change in stack starts with the hash starts with 63F7. And here it's saying that it's going to apply the normalized snapshot example in code resources shim. And so this is actually being applied to the Lambda task here. So it's the first thing that happens. And then it says that it's applied that. And this basically will encode resources or encode properties in a custom resource. And so this is sort of unrelated to what we're talking about today, but this is a transform that gets applied to the greeting task lambda. Then after that, we'll have our pre-normalize echo. And so this is the stack. It has a child pre-normalize echo, and that has pre-normalize echo shim. And that's this guy here. So this is before we normalize the snapshot, we want to echo what the template looks like. And so you can see here's our first resource here. If I go down, I'm going to try to get past this relatively quickly. It is a rather long template because the when you start using custom resources, you end up with a lot of stuff. And here we go. So now you can see that it says that it's applying normalized code S3 key shim, and that's part of normalized snapshot. Now let's go take a look at that over here in our AWS toolkit. So I'm going to refresh that. Here's our stack normalized snapshot example, and then here's my ensure change in stack resource. here. It doesn't really give us very much information there. Here's my greeting task lambda. So this has a function in it, and it has a task, and this is a custom resource, and it has this run resource always, which is what adds the salt, and it has this encode resource, which is actually what encodes the resource, and that encoded resource is run where? Oh, it's run last, so it's run as part of the writer pass here. So it's basically if you ran any transforms or string transforms on the properties, those would run first, and then this encode resources, which encodes the properties, this runs last, which kind of makes sense. But that's just on the lambda task, and then our pre-normalized echo, which is the echo that wrote all this out here, wrote out the template, that's here. And so this is a child of the stack. And since it's a child of the stack, the shim that goes with it, so remember, this is an L2 transform, and it has as a child an L1 transform, which is actually the thing that gets applied to the stack. It will call back to pre-normalized echo here, and then that will do the actual echoing. So these shims basically allow you to add the transform in a logical place, and then the shim will go into the place that it needs to go in order to do its job. So as I said over here, the next transform that we have is normalized salt. And normalized salt is a string replacer, which is a kind of string transform. And that means that the template needs to be a string in order for this to run. So here we ran our pre-normalized echo transform, and that was not really a problem. But then we wanted to, under normalized snapshot, we want to normalize our code S3 key. Okay, well, since that's just a regular transform and it doesn't require any sort of serialization in order to run, it can just run directly, and therefore we make its shim a child of the transform directly. And so this shim here, since between this and the stack there are no L1 or L2 resources, instead of being attached to an L1 or L2 resource, this normalized code S3 key will be attached to the stack, and that's what we saw right here. So our normalized code S3 key transform, its shim transform will run when we're applying transforms to the stack. Okay, cool. Now the next thing we added was normalized salt. Well, normalized salt requires that the template be in string format. And so in order to do that, we now need to turn it into a string. And the way we do that is here we added orders. So when you add a string transform, which a string replacer is a string transform, let's see if we can, see that? So a string replacer is a string transform. What the string transform will do is it will add these orders. So it added pre-reader and reader, string transforms, parser, transforms, and writer. And what this does is this gives you places to do things like stringify the template so that you can then run a string transform under it. And so that's the normalized salt. String transform ends up under here. So this normalized code S3 key just put its shim under here. Normalized salt said, oh, in order to run, I'm going to need to run on a string. So it added these orders. It stringified the template, and now it runs normalizing the salt, basically changing the salt value from build time to a normalized value. So that's cool. And then in order for this to work, we now have to take the string version of the template and turn it back into JSON, and that's what this parser does. So here you can see that we ran our normalized code S3 key, then we ran our stringifier, then we ran normalized salt, and then we ran our parser, which is what you see over here. So now that this has been done, now we have, as part of our normalize snapshot, we have normalize ensure change in stack. Now this is a normal transform. So this guy, if we go take a look at this, it's a transform, and in its apply, it just goes and deletes any resource that starts with ensure change in stack and then adds another one. So it's working on JSON. It's working on a JSON object that has been loaded into memory. And so that is under here. So under transforms, we have normalize ensure change in stack shim. And then down here, we have post normalize echo shim. And that is actually, if we go back to our lesson stack, post normalize echo is the echo transform that's here. And so that will run last. So you can see here, we ran our stringifier, and then we normalized the salt, and then we parsed, then we normalized ensure change in stack, and then we did a post normalize echo. So we did an echo after normalize. And so that just ended up here under transforms. And so our post normalize echo is going to show us once again, well, here's our service role and reverse, and there's a whole bunch of other stuff. And if I go to the bottom of this, you will see here's our ensure change in stack with the correct logical ID, and it ended up at the bottom after the CDK metadata because the CDK metadata got added as part of synthesis, and since our transforms ran at the very end of synthesis, that's why this got added here. If you remember how normalize ensure change in stack works, it kind of makes sense since it deleted the existing one and then added a new one that it would end up at the very end. So there we go. That is how I made it so that when I am running my tests, the things that I expect to change will be turned into values that do not change from build to build, and that way my snapshots work perfectly. And so this really made it a lot easier for me because when I check in now, I don't have to go through all of my snapshots and ensure visually that the changes that are in them are ones that I expected. Instead, I've added these transforms to my snapshots to make sure that those things won't change from build to build. And that's why I can put these snapshot files in my tests here, and I am sure that every time I build these, I'm not going to have any changes, and if I do have changes, that probably means that there was a problem in the code because I made a change that I did not expect to happen, because all of the expected changes are accounted for here. So there you go. That just kind of gives you an idea of how I like to use transforms and how they make it easier for me to work with the CDK. And I hope you guys enjoyed today's lesson, and I'll see you all in the next one. Bye bye.